Hey folks, today's episode was sponsored by Datadog. It's a cloud-scale monitoring and analytics platform. Datadog was built to bring clarity to complex dynamic applications in the cloud, on-premises, in containers, or wherever they run. With beautiful dashboards, distributed tracing, and seamless integrations with more than 200 technologies, including Azure and Docker and PagerDuty, Datadog provides deep, end-to-end visibility into the health and performance of modern apps. Visualize key metrics, set alerts to identify anomalies, and collaborate with your team to troubleshoot and fix issues fast. I'd like you to try it yourself by starting a free 14-day trial today. Listeners of this podcast will also get a free Datadog t-shirt. Get started at bit.ly.com/DatadogShirt. That's bit.ly.com/DatadogShirt. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Ben Wheeler. He is a teacher and a developer who has taught both kids and teachers how to code. How are you, sir?
I'm doing well today. Thanks so much, Scott. I'm excited to be here.
Yeah, I'm excited to talk to you. You know a whole bunch of stuff about Scratch, and pretty soon you'll be working on Scratch. Is that right?
Yeah, well, I think of myself very much as a beginner, and I really encourage a lot of the teachers that I work with out there and parents to not worry about being an expert. So I guess I do know a lot, but really there's tons of kids out there who use Scratch every day who probably know more than I do.
But you're going to be working at the MIT Media Lab on Scratch, so there's some kind of bona fides that you get for doing that.
Yeah, well, I'm going to be a beginner at doing that for them for a while too. And that's a mentality that I really try to encourage in the students I teach and in my daughters of, going into these new situations and starting at the beginning and learning from there.
That's a really important perspective, I think. I've always used the term, I'm a professional amateur. I'm learning every day. I just do it professionally, but it doesn't mean I have any idea what I'm doing.
It's funny. I just came today from Staten Island. I visited a school where there were some teachers who had taken a workshop I had done in February, and they had done Scratch for the first time in February. And I got to see them doing it with their third graders today and also doing some robotics. And then we met afterwards to talk about it. And they were talking with such excited energy about how much they love being beginners at this. It was really amazing. They said, it's funny, we've been teaching for 30 years and we sort of thought there was nothing left for us to learn. And now we're doing this thing and we feel like we're really not that good at it yet, but it's actually really exciting to be in that state and to be exploring with the kids.
Definitely. And to not lose that sense of freshness. I mean, I've been in software 25 years professionally and 35 if you count, since I was a little kid. And I'm still finding myself a couple times a week looking at something on CodePen saying, how did they do that? That is insane.
Oh my gosh, absolutely. I've been coding for 30 years. And I still, all the time I'm seeing things that people do and I'm thinking, oh my gosh, I wish I made that. How did they do it? I don't know if you know Nikki Case.
No.
JavaScript online sort of interactive storyteller. But Nikki Case does stuff with JavaScript that is so brilliant. It makes me feel like the first time I ever saw a program running on a computer.
Oh, wow. I will make sure to put links in the show notes so that people can see that. So here we are, two old people on a podcast, with the weight of history. And, I was looking at God of War 5 earlier, just staring at it, just staring at the graphics of the thing. And I ended up watching a 20-minute video about how when he hits like a tree with his axe, how they make the axe stop, but the bones in his arm keep moving so that it's not purely an animation of him swinging his arm. It's literally the physics of he hit the thing and then his shoulder and his elbow and his muscles kind of go jiggly because that's what happens to your arm when you hit something with an axe. And I thought that was just so fascinating. And then I'm realizing that I'm trying to teach my 10-year-old how to do Hello World at the text, the text level at a console. Am I teaching my child computers wrong?
No, it's so funny that you bring that up. That's something I think about all the time. And it's really a constant dynamic in my work with kids and in the teaching that I do to teachers, because when I was a kid, there wasn't that big a difference between the program that you could make in a couple days as an amateur programmer who just learned last week and the sort of professional code that was running on the computer. It might be something like Oregon Trail, and that might be impressive. But really, if you learned everything that you could for a year, you could make Oregon Trail back then. And then there were lots of programs that were really just sort of text simulators. I remember there was a really popular one in high school that kids would just play on their Texas Instruments calculators that was text-based. And that was fun and catchy. And you could make those kind of simulators, a lemonade stand, launching a starship and how much fuel you have to put in to get it to get to escape velocity. And you could write those in text in an hour and have people be playing them, that day on the same machine. And the distance between thought to execution and how proud you'd be was very short. And now it's a tricky thing because when I show kids intro to coding apps on a tablet that are very flashy looking, a lot of the times those flashy looking ones don't actually get very deep into the programming from a creative perspective at all. And then vice versa, the programs that do actually give them near infinite expressive power, whether they're text-based programs or a block-based program like Scratch that has a lot of flexible creativity, those don't initially seem as impressive. The graphics seem simpler because it's not doing as much for you. It's waiting for you to invent things. And it's tricky. It means, I think, that you need to show students some of the end products that they can make with this kind of power, and then almost rewind from there and say, okay, let's look at this impressive Scratch program and let's look inside and look at the code. All that code looks a little overwhelming and hard to understand. Now let's rewind and let's just look at a few of those blocks at once. And I find that it really helps to illustrate that connection so that students are saying, oh, right, I'm at the beginning of a process that can lead there.
It does make you wonder, though, have we made such a stack of stuff that's so high with so many layers of abstraction? Are we asking a lot of them to say, now work hard for 2 years or 4 years or 5 years, right? Like there's always the talk about how old you have to be before you're a senior engineer, and like, the young people today, they want to be senior engineers in a week. We've built such a large stack. I don't even know where to start.
Yeah. I mean, I find this as a programmer because in addition to my teaching, I'm a professional programmer and I've programmed in a lot of different capacities for a lot of different companies and clients. And it's harder and harder to keep up, really. I feel like, I don't want to name particular past years, but when I was in college, say, it still felt like you could pretty much know everything as a programmer. And of course, that wasn't quite true, but you could, be reasonably caught up with where AI was at, and you could be reasonably caught up with where kind of flashy front-end HTML interfaces were that just had a touch of JavaScript. You could be reasonably caught up with, high efficiency code that's really, getting close to the metal. And it feels like that stuff, with the broadening of the field, there's been this sort of enforced specialization where now I feel like I've had to just kind of let go of some domains that I used to be pretty caught up on. And, just knowing something like React or Angular or Vue or, these frameworks that have tremendous power to make these interfaces that we couldn't have dreamed, a few years ago, but that takes so much constant, not just learning a particular language like JavaScript, but then learning these ever evolving and ever changing conventions. I mean, I've been sort of steadily learning React now for the last 2 years, and I feel like it's like trying to catch a jellyfish. Like it's always squirming. By the time you learn one version of Redux, now there's this new version that's supplanting it, and everybody's using this different set of plugins. And now it's Webpack. It's no longer Grunt or Gulp or it's harder and harder to keep up. And that is a real challenge of the field.
Doesn't it lead that we should teach the kids the fundamentals, right?
Yes.
Like there's always going to be a new wrench or a new screwdriver, but if you learn the fundamentals of carpentry, you should be okay. So then doesn't it follow then we should teach the low-level stuff and the historical context of computer science?
Yeah, I mean, historical context is really interesting, and I think it's somewhat a separate question in some ways. But I really think it's incumbent on us who are working to push computer science education forward to really emphasize that it's the thinking of a computer scientist and the process of debugging and iterative development. Those are the things that I really think we need to make sure kids are having experience doing. And a lot of people who don't know as much about computer science, they're thinking of it from a vocational perspective, which is totally reasonable. They want the kids to know things that are going to be practical immediately and that are going to, lead into jobs, whether it's a job in computer science or it's just knowing about how computer science works and being able to apply that to their work in lots of other domains. And that's totally reasonable. And sometimes I feel the urge to resist it and to say, absolutely. But in order to be able to guide themselves towards wherever the particular technologies are when they're graduating high school in 10 years or however long, we need to make sure that they have the ability and the experience sort of learning how to learn and learning how to work through computer science kinds of problems and to think the way that you have to in computer science, because it's a different kind of thinking, just like visual art is a different kind of thinking than math or than music and English vocabulary. That they all sort of use these somewhat different but overlapping parts of our minds.
Mm-hmm. Someone on the show recently told me to try to avoid using the term squishy or soft skills because it diminishes the real science behind those things. We've heard the terms like IQ and EQ, emotional quotient, but I still find myself coming back to trying to figure out a word to describe those kinds of things. And as someone who has been programming for so long, it's so hard to define what feels like. You use the term jellyfish, when you describe how do we teach people how to think. There's science behind that, though, right? In the educational psychology world.
Yeah, I mean, there's a lot of different kinds of science that come to bear. You can bring to bear from different angles. I mean, there's a lot of research around learning how to learn, and I'm forgetting the name of this wonderful professor. This woman, I was just listening to an interview with her on the Farnham Street podcast, and she's the author of this book, Learning How to Learn, and she runs an online course called Learning How to Learn, and she does a lot of distilling and summarizing research into...
Oh, Barbara Oakley.
Yes, that might be. But she talks a lot about what we've learned about the processes of going from familiarity to proficiency in different areas. And she's really thinking about that from the perspective of, say, a college student who's trying to really learn a lot of history that they're going to use on their test and in a paper and refer to in future years, and how just reading and even reading and rereading and underlining, those things that we think of as kind of active, attentive reading, those things alone don't quite make the information stick in your mind. You have to run into a problem with it and have a moment of not being able to solve it, and then push your brain to dig deep and find the information. So if you're learning about the Spanish Armada of 1588 or whatever it is, you have to have some moment where someone's saying, and what was the greatest crisis that faced Spain in the 16th century? And you have to think, gosh, what was the biggest crisis? Oh, yeah. The crash of the Spanish Armada in what year? 1588. And when you have that problem and then you work through it, all of a sudden the pathways are lit up and they're connecting in this new way. And, that situation, what I described is almost more of a sort of a memorization example, but I think it really translates broadly into all kinds of ways that you learn how to think. Yeah. And in computer science, I think a lot of that is learning how to hit a wall with a bug, which happens over and over for everybody who does programming. You hit a bug and you think, this is impossible. There's no way this is going to make sense. Something is going wrong. I'm looking at the code. It's wrong. This is a bug that will never be understood. And always, if you persist, it always eventually is. And I can't tell you how many times, hundreds of times I've had that experience. And it's only having had it dozens and dozens of times before that I can tell myself, remember, Ben, you're going to get through this bug and you're going to figure it out. So what's the next step? And what's the next step? And students really need to have that experience because it's very different, I think, in a lot of ways than the kind of schoolwork that we're asked to do in other ways. Schoolwork that's perfectly worthwhile. It just doesn't involve that absolutely getting stuck and having no idea how to proceed. A lot of the time, we have so much experience ramping up math slowly and steadily, and that doesn't mean that people don't feel totally left behind sometimes. But when they're totally left behind, often they don't necessarily have a way to get past. If you haven't learned long division and you're faced with a long division problem, I mean, you're not going to invent long division on the spot using somebody else's terminology. So what's kind of amazing about computer science that can apply to students' experience in other areas as well is this idea that you have an algorithm and you have an approach, and maybe your code has an algorithm that's not quite working and you have to go and change it. And maybe sometimes you have an algorithm that's not quite working for doing a homework assignment or for learning a particular concept, and you have to go back and revise that. But there's always a way to revise the algorithm in question so that you can proceed.
Definitely. I feel also that understanding that there's no black boxes in computers, that there's always a way to kind of crack it open and look underneath if something goes wrong, right?
Yeah.
If the website doesn't look right, once you know that F12 tools exist, you can do that. And if you, you can see the HTTP on the wire, but I think people get stuck where they don't know that like HTTP is a thing because they learn at a boot camp and they learn CSS and HTML and don't understand the network, that the network exists. They type Google, they hit enter, and a miracle happens.
Absolutely. And those practical techniques of debugging, I think it's so important to really focus on those when they come up in class. So that's actually something that we come back to again and again in the training sessions that I've run with the New York City public school teachers. We talk about how inevitably when you're teaching technology, you run into bugs that get in the way of the lesson that you were going to do. There's a Wi-Fi problem. Or, just today, a teacher was using Dash and Dot robots from Wonder Labs. And always with Bluetooth, there's going to be some kind of problem. Things always go wrong with Bluetooth. But instead of thinking of that as a reason why you shouldn't even try the lesson in the first place because it's not going to be perfect, I was really encouraging the teachers, when that happens, get everyone's attention together and say, okay, what's our plan? How are we going to debug this? Because sometimes I feel like the worst thing I can do in my moments as a teacher when I'm in a rush is, I think, I just have to turn this off and on again. And I just, take it out of a student's hands and I just do it. And in my best moments, I tell myself, no, wait, even if the only thing the student comes away with today is realizing that Ben, the all-knowing teacher, didn't know the answer to that question and sat down with me and we made a list of things that we're going to try, and we tried each thing on that list. And even if it ends up not working, just that experience of saying, all right, we have this black box problem where this thing just simply isn't working, but that's not the end of the story. That's the beginning of the story for us. And there's actually something that we can learn every time something goes wrong. So in my classes with students, I use a phrase, it's sort of a catchphrase of the class, which is cool malfunction. And we've had a lot of cool malfunctions, a lot of short circuits, some batteries that start to have smoke come out of them.
I was trying to explain to my non-technical spouse there seems to be a thing where every time I go on a business trip, something in the house breaks. It just seems to be, it's Murphy's Law of the person that travels for work. And every time I leave, it's probably, I have to get a certain number of miles away before something in the house breaks. And now with all the, all the voice activated devices that I dare not speak their name and IoT stuff, I left last week. It was a light bulb. I left, the DVR broke. And then she calls me and says, how can I fix X? I have no idea. I really, truly have no, so I just walk her through the checklist, turn it off. Does it have an IP address? Reboot the router, those kinds of things. Why have we put a barrier between us, the techies, and the normals, even in the labeling of them just now in that sentence, such that they feel that they can't experiment or turn things off or poke at black boxes? We really need to break through that.
Yeah. There's there's the book Zen and the Art of Motorcycle Maintenance. And I often think back to that because that book opens with this episode where the author is taking a trip with friends, and he's on a motorcycle that has a million things wrong with it, and it's far from state of the art. But he's taken that thing apart and put it back together dozens of times. And so when things inevitably go wrong, it's not a crisis. But his friend who bought a beautiful state of the art motorcycle, the first time something's not working, he's got to just wheel it to the garage and wait for somebody else to solve the problem for him. And the author presents this as sort of a philosophical difference to some degree, but it's really a statement on the direction that things are going. And you look at vehicles, cars. I mean, my parents and their friends used to do a little bit of tinkering with their VW bugs in the 60s, and a lot of the time they could fix things. But nowadays, more and more in a car is run by a computer that you just don't have access to. And there's even laws and real active legal debates with groups like the Electronic Frontier Foundation taking a big active voice, because there's laws that make it illegal, literally illegal, for you to open up certain types of computers and modify them and, have them do what you want instead of what the company has decided.
Hey friends, this is Scott. Listening to podcasts is a great way to keep up to date on technology, since we're always learning as software people. And you can also find a job by listening to a podcast if you check out our new sponsor, Hired.com. That's HIRED.com/Hansel Minutes. On Hired.com, software engineers can get interview requests from companies that want to hire you. Each offer will have the salary and the equity up front. You can view those interview requests and accept, reject, change the offer before even talking to a company. It's a great way to find out what's out there and maybe make a move. They're working with over 6,000 companies, from startups to large companies, from 14 major tech hubs throughout North America and Europe. What's great about this is it's totally free for software engineers. And if you get a job through Hired.com, they'll ordinarily give you a $300 thank you bonus. But if you use our special link, they'll double that bonus, so you will actually get paid $600 when you accept that job. Now, if you're not looking for a job, but you know someone who is, refer them to Hired.com/Hansel Minutes, and they'll give you a elite bonus, a $1,337 bonus when they accept a job. So check them out at Hired.com/Hansel Minutes. Do you think that I wrote a blog post a while back called "Is Technology Killing Curiosity?" And I'm wondering if the ease of access to the sum of all human knowledge may make my 10-year-old less impressed. When we do Hello World in a loop.
Yeah, that's such a great point, because that ties back to the concept of how impressive things are today. You look at Legend of Zelda: Breath of the Wild, and it's literally awe-inspiring, and it's the product of tens of thousands of hours of human effort, and me or my class, we're never going to make something that can approach that in a lot of ways. But at the same time, there are technologies that still very much are lo-fi that do inspire awe. And, you look at fiction writing, for example. I mean, my daughters are big fans of plenty of flashy apps, but they also really like reading because it still has the power to give them experiences that most movies and TV shows don't often get close to matching. And they like the Harry Potter movies, but they don't stop reading the Harry Potter books. And so I take some hope in that even though we have this magic access to information and to things that are dazzling, that it hasn't meant the end of that curiosity, even though it can be quite a lot of competition with it.
Yeah, I'm really trying to push my kids also in other ways in media. I was trying to get them to watch, Buffy the Vampire Slayer? Because this is classic literature, right?
Yeah.
The television equivalent, or, what was the other one? Smallville. And my 12-year-old got like 3 episodes in, and he says, I couldn't do it. The graphics are so bad. And I don't know whether he means the special effects or the fact that it's 4:3 or that it's like recorded on VHS tape, but he called it the graphics. And I was like, yeah, but the story, it reminds me of when my parents tried to get me to watch black and white films and say like, but it's so good. You got to push through. I feel like we can do that with Raspberry Pis and Arduinos and still force them that there's joy in blinking an LED.
Yeah, I mean, there is a lot of joy in that. I've just been doing a little bit of microbit with my daughters mostly, and there is still an excitement of, wow, here's this thing whose circuitry I can see, and I'm deciding what it's going to do, and then it's doing it, and that does still have some magic, even though it's just a few blinking LEDs. But just about the movies and TV shows, I mean, that's something I've really definitely encountered that with my daughters. I love movies, and sometimes it's been a success when I've tried to introduce my daughters to movies that I really think they'll love, and sometimes it's not. I tried to get them to watch Adventures in Babysitting, and they just found it too slow.
Yeah.
And,
Actually,
go ahead.
with something just that'll make your mind, like I just recently watched Cobra Kai, not appropriate for kids, but appropriate for people who like Karate Kid. So I had the kids. Good. It's fantastic. So I had the kids watch Karate Kid, and they didn't get it. And I was like, why didn't they get it? It turns out that the protagonist, the problem, the crisis is bullies. And there's a zero tolerance bully situation at like every school now. Like, I'm not saying bullying doesn't happen, but it doesn't happen in that way that it did in the 90s, where from Pretty in Pink to The Breakfast Club, it's all bullies. And they 5 minutes into Karate Kid, they were like, oh, where's the principal? The principal would have stopped that a second ago.
That's so funny that you mentioned it. Just the other day, my daughters were kind of asking me about bullies. And again, it's not that there aren't power dynamics and cool kids in their class and kids who are too rough sometimes. But you're right. They're in first grade and third grade, and bullying just isn't really something that they've run into yet. There's nobody who is at the bottom of the pecking order. And sometimes in my stories of my childhood, I've talked about, that there was a kid who was having a hard time and people were picking on him, and they sort of don't quite know what I mean. And that's not to say that they don't sometimes feel like one member of the friend group is not getting her fair share, but that dynamic doesn't seem like it's a problem anymore. And I guess there's a lot that's really wonderful about that. Yeah. Sometimes I do wonder if we as adults are managing so much for kids that they're not having the chance to discover and work through some of those problems.
Yeah, that's true. And to be clear, before we get letters or tweets, we do recognize that bullying is a huge problem, particularly if you are of a underrepresented group or if you are LGBTQ. But I think we're just pointing out that it has changed in some fundamental, measurable way since the 90s. And I'm just using Karate Kid as an example. One thing I wanted to pop back to, talking about the LEDs, my kids learned on Scratch. They learned their first programming language, I would say, was Scratch. Can Scratch talk to Arduinos and LEDs and flash things? Because I've never really felt like there was an attachment between this draggy, droppy for loop thing that makes a cat spin and the physical world.
Yeah. So the answer is sort of. There's a website called ScratchX, and it's not advertised very much by Scratch. It's considered experimental. And there are a lot of different extensions that different people have written for Scratch that all generally involve a fork of the Scratch code to add this extension code in, and then a plugin for a browser like Chrome so that the Scratch code in the web page can connect to the computer and the computer's own USB connection or whatever it is, maybe Bluetooth, to be able to communicate to the device. So there is a lot of that stuff out there. It's still mostly in an experimental state. And I think it's gotten the farthest along with Lego WeDo, which is, one step simpler than the Lego Mindstorms robotics environment. And the WeDo stuff is really wonderful. I have seen a lot of student creativity with it. And like I said before, part of the Scratch team's excitement with this new version of Scratch 3.0, that's coming out this August, is that there's a whole long list of applications that are going to be built that connect to Scratch and provide this kind of bridge. So one of the very big ones is Lego Mindstorm's EV3 or Evo, whatever it's called, is going to have a Scratch 3 component. I'm not sure exactly what the date is on that, but that's the plan.
Oh, that's good to know. I mean, I feel like that fixing that or, making that happen would definitely open up a world that would be even more interesting. Like the Internet of Things as it relates to Scratch would be definitely powerful.
Yeah. And I don't know how much you've played around with different robotics, the Dash and Dot robots, for example, which are really wonderful. Kids light right up when they see them and they immediately want to touch them and press the buttons and explore them and control them. And if you use their kind of block-based programming environment, it's based on Blockly, there's a lot of cool stuff there. But there's also stuff that I feel sometimes like I wish was there that's missing. And Scratch connecting to more and more of these robots, I think is really exciting because as these students that I was working with today, for example, who were using Dash and Dot, they're getting very familiar with Scratch in their third grade class. And if they could use that knowledge and translate that even more directly and be able to use the events and the when background clicked kinds of things so that they could be programming more in depth even than they're able to do with the somewhat more limited set of blocks that are available now. I just think it would be sort of a win for everybody all around.
Yeah, absolutely. And it's going to be nice to have you, as it were, on the inside working with the MIT Media Lab to make Scratch even better. Yeah,
I mean, I'm just about to begin, and I'm hoping that I can dive in and contribute.
That's fantastic. Well, people can check you out at adaandleo.com. This is a nonprofit you have?
Yeah, it's the Kids Technology After School and Weekend program that I've been teaching kids through for several years.
Very cool.
Yeah. I have a technology and education newsletter called Robot Owl. Ooh. I've been writing about these issues and making recommendations and talking about what teachers are telling me in the field. And so it's basically for teachers and parents and anybody who wants to spark an interest in kids and in all this sort of thing, innovation and technology and creativity. So that's robotowl.co.
All right. And I will put links to Robot Owl to your own website at techno-social.com, as well as Ada and Leo, and all of the different robots and things and Scratch and Microbit and all of these links I've been collecting, and I will all be in the show notes. So be sure to check those out and follow Ben on Twitter. Fantastic.
Great talking to you, Scott. And I'm excited for this kind of creative message to go out there.
Absolutely. This has been another episode of Hansel Minutes, and we'll see you again next week.